In this problem, we're asked to solve for the height of the building. In the problem statement, we're told the distance between the ground and the bottom of the window and the length of the window. So solving for the height of the building really amounts to solving for this distance y between the top of the building and the bottom of the building, because the sum of these three distances will be equal to the height of the building. The main idea in this problem is again practice using the kinematic equations. The first step is to decide which kinematic equation we should use. We want to solve for y, which is the distance between the top of the building and the top of the window. The quantities that we know are v1, the velocity of the flower pot as it passes by the top of the window, v0, the initial velocity of the flower pot, which is equal to 0, the amount of time it takes for the flower pot to traverse the length of the window, L, the length of the window, h, the height of the window above the ground, the mass of the flower pot, and the acceleration of the flower pot, which again is the acceleration of gravity. If we look at our kinematic equations here, we can immediately eliminate the first three because they are all functions of time, and we do not know the amount of time it takes for the flower pot to go from the top of the building to the top of the window. That leaves us with this fourth equation here, where v will be the velocity of the flower pot as it passes by the top of the window, v0 is its initial velocity, a is the acceleration due to gravity, and y will be the variable we're solving for. We now substitute in the known quantities into our kinematic equation, and we can solve for y, the distance between the top of the building and the top of the window. With our expression for y, we can now complete the goal of solving for the height of the building. We substitute in the values in the problem statement and the value for v1 found in part A to find that the height of the building is 30.88 meters.